just in time to probably go home for one more day, to come back for one day, to then have a 3-day weekend. Because, of course, family day is Monday. I know, right? Yeah, just blow off the next 2 weeks, come back for 4 days, then take 2 weeks off for spring break. We'll call it even, right? Okay. Guys, listen, please. Listen, please. As we go on with this next few questions in our notes, please, please, please leave some space. Okay? Try not to fill up the whole area that I've given you for work, because we're going to come back and do something with these in a minute. Well, not a minute. A little longer than a minute. Everybody okay? Yeah? Yeah. All right. So, remind me again. The page we were doing the cereal box on for you guys is page 22, or is it page 32? 22. It's 22. My pages are 5 pages ahead of you, yes? Yeah. Okay. Jenna. Did you start surface area? Yes. We did just this one question, did we not? No. Oh! We did nothing with surface area. Well, that is a horse of another color. Oh, I see what has happened, Mr. Myers. You're a dunderhead. You have mixed up your yes, you have mixed up your books. And you put the other grade 10 class in this grade 10 class. What a clown. I apologize profusely, ladies and gentlemen. And it will not happen again. So you guys should be looking at this page, but you will have a different font. You appear to have bats and dragons, whereas I have king things balloons. This is where we are, yes? You should be looking at a blank page 22. Yes? Yes? Everyone? Excellent. Now, much like if we were to go next door and ask Mr. DeVries what the worst thing that calculus students are in math, and he would say fractions. If I were to go to Mr. DeVries now and say, what is the worst real life thing that kids are bad at in high school math by the time they get to grade 12? And his answer will be surface area. Not because you guys can't do length times width. That's not the problem. Not because you can't read a formula. That's not the problem. It is because you do not understand what is actually happening when you do these questions. That is where you get into trouble. Because you don't actually understand what is meant by the difference between surface area, volume, and surface area in real life and surface area in a math class. Okay? So please, 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 even though all you need to do to get the A in this section of this course is to know how to work a formula, it is not that easy. So please make sure you pay attention. Okay? Because you actually have to think. It's not just filling in the formulas. All right. Let us move on, cabbages. We will be starting with the surface area of 2 kinds of shapes. Those 2 kinds of shapes are closely related, okay? By the way, to those of you who are just giggling, I am not calling you cabbages. What I say is let us move on. Let us. Let us move on, cabbages. It is not a put down. I am not calling you vegetables. Yes. All right. So the shapes are broken down into 2 categories. These 2 categories follow similar rules, but it's not as, again, binary as one would think. It is not either one or the other. Okay? So the first shape that we deal with, the first is a prism. Now, a prism has a definition. Does anybody wish to attempt to define a prism? And when I say define a prism, I do not mean give me an example of a prism. Define what a prism is. Can any of you do so? without telling me what one looks like? Excellent. Now, tell me what is a prism. Now you can tell me what a prism is. I notice I didn't ask you to define it. Oh, we can't do that either? We're in trouble. Is this a prism? Tavleen?
Okay. I think it's like a prism has like a 3D shape.
Excellent. Good start. It is a three-dimensional shape. You cannot have a two-dimensional prism. Okay? Good job, Tavleen. So a prism is a 3D, and I'm lazy, 3 dimensions. Dimensions are measurements. The dimensions that we are concerned with are length, width, and depth, or height, depending on how you want to talk about it. That's where it starts getting confusing. What do you mean by depth? What do you mean by height? Those are the divisions we care about in grade 10 math. Are there multiple other divisions? Yes. I think the physicists of the world have decided we're up to something like 29 dimensions. I care about 3. Length, width, and depth. So, 3 dimensions, Tavleen is correct. A prism has to be 3-dimensional. Those 3 dimensions, length, width, and depth. What else, Tavleen? Go.
Okay, I don't know if this will make sense, but it's like, if you have like a shape and a shape and it's like what connects the shape.
Yes, that is very, very close to right. A 3-dimensional shape consisting of 2 polygons separated by rectangles. Now, you will see that I've crammed this in over here, yes? Even though I left a big space for definition. That's because I want to show you what I mean, okay? The definition, you have to take a polygon. A polygon is any closed shape, okay? So, take any shape. We're going to do it real easy, and we're going to draw a rectangle. That's a polygon because it's a closed shape. Right? I could also have a triangle. I could also have a hexagon. It doesn't matter. Everybody cool? All right. Rectangle. Now, it repeats. So I got to have another one of them. So I'm going to draw that same rectangle over here. And then I'm connecting it. And those connections are all another rectangle. Okay, if you can't draw a 3D that is transparent, just draw it this way. Draw a rectangle. Then up to the right, just draw the L and connect the 3 corners. Is everybody cool? Right? Now, using this example that I had here, this shape right here that faces you guys, if you were looking at it perfectly, could you guarantee to me that it has a depth? In real life, of course it does, because even if it was a piece of paper, it would have a millimeter of depth, yes? But in a math class, you can only guarantee right now that this has 2 dimensions, yes? It has a length, where my nose is. Wait. Went down the stairs. Screw you guys. And it has a width where my hands are, yes? All right. So this has 2 dimensions, length, width, right? And it is a rectangle, agreed? On the back, what do I have? The same thing. Same length, same width. What is separating them? This little rectangle. And this little rectangle. Got it? So this is a prism. We would name this prism a rectangular prism because we started with a single rectangle and then we repeated it to make the whole prism. Everybody cool? What if this was a triangle, like a Toblerone bar? Then it would start with a triangle and it would repeat all the way back and I would have 3 rectangles separating them. Cool? So that would be a triangular prism. What if I stacked 1,000 stop signs on top of each other? What would I have? One more. Octagonal prism, because I would have 1,000 hexagons separated by 8 rectangles. Got it? Everybody cool? We name it based on the shape that starts it. Okay? Now here's the first bit of confusion. The shape that starts it, we call the base shape. When I say base in geometry, what do you guys usually think that means? The bottom. That's a problem. This is what I mean by memorizing formulas over what we're talking about, yes? If you were to measure the distance from my feet to the top of my head, what would you call that distance? What is the measurement? What is the name of the measurement we give that goes from the bottom of one's feet to the top of one's head? Your height. Agreed? Because it goes from bottom to top, yes? And the bottom of my body are my feet. My feet are the base, yes? What if I stand on my head? What is the base? Don't be scared. If I stand on my head, what is the base of my body? My head. Does my height change, Stanley? No, it does not. So calling something the base sometimes means the bottom. But it also means where we start from. Understand? Now the next question is this. What if I lie down on this desk? What is my base? My back, right? So my height must be from my base to the top, yeah? So that would be this distance, wouldn't it? Except here, where we'll go, but we can't count that. Assume I am, which is stupid, because I'm obviously, right? Is this my height? No, of course not. My height goes from my feet to my head. No matter where I turn my feet, that's my height. Understand? So in geometry, no matter where I turn, heights and bases sometimes move, but the actual measurement doesn't. Does everybody understand what I'm saying? Okay. So, where did I put my magic pen now? Got it. So the definition here is the base shape repeats. Now, the base does not necessarily mean, it means basic, not the bottom. Does everybody understand that? Sometimes the base is the bottom, which is what I mean you have to think about these. Everybody cool? Let me give you an example. That's a rectangle, yeah? You don't need to write this down. This is just what I'm talking about. If I wanted the area of that rectangle, we would do length times width, wouldn't we? Right? Everybody cool? Now, if I take that rectangle and I cut it in half, what do I get? I now have a triangle, yeah? The area of that triangle is half of the old rectangle, yeah? And in a rectangle, we would go length times width, would we not? But we don't say length times width when we're talking about triangles, do we? Because triangles don't go length and width. Triangles go up in the air, right? Duh. So what do we say? We say base times height, correct? But we got to divide by 2. Everybody knows what I'm talking about, right? Now the problem is, I will give this exact lesson that I just gave you guys to kids, and then I would say, great, now tell me the area. Oops, that was a bad drawing, because that's 90 degrees. That's 90 degrees. 7 and 6. And kids won't be able to tell me that area because it's been turned. There's no longer a base and a height, is there? Right? This, everyone wants to call this height because it goes straight up. Turn it a little, kids can't do it all of a sudden. Everybody understand what I'm saying? Don't be fooled by that. Base is just a word we use so we can write formulas. Cool? All right, so back to where we were. We covered rectangular prisms. Oh, and that's how we name them. They're named by basic shape. So we've already drawn a rectangular prism. Here are the other ones you guys are mostly going to deal with. Triangular prism. Just draw a triangle, draw 2 lines back from it, then connect them. That's a triangular prism. Why? Because a triangle has repeated all the way back and it's separated by rectangles. It's a Toblerone chocolate bar. Cool? Everybody good? The other one you guys are going to deal with is a circular prism, which is a cylinder. Yes? Everyone's like, Mr. Myers, a cylinder is not a prism. Yes, it is. What shape is that? A rectangle, right? Now what shape is it? Cylinder. 2 circles, repeating polygons separated by a rectangle. So cylinders are a circular prism. Everybody cool with prisms? Easy peasy, right? Okay. The other one we are going to do are pyramids. And pyramids, again, 3D shape, starting from a base, and meeting at a single point. But it follows the same rules. We start with a bottom. Draw it this way, please. A line and then go off diagonally. Draw a triangle at the front and then connect the back. That's a rectangular pyramid because I started with a rectangle on the bottom. Now again, would we call that the base? Think of the pyramids in Egypt. Would you call the rectangle that's the bottom of them the base? Of course you would, because the pyramid is sitting on it, yes? But if you go to the Louvre in Paris, have any of you been to the Louvre in Paris? There is a giant pyramid there that is turned over and pointing downwards. If you haven't been there, you may have seen the Da Vinci Code, which is set in the Louvre in Paris. Right? I know, right? The French people are like, God, shut up, man. I'm going to stab him in the eye. I know, right? Because my French is atrocious, but I have fun with it. The pyramid is turned over and sitting on its point. Where's the base? Where's the base of the pyramid if I turn it over and sit it on its point? It's still the rectangle at the top, even though it's no longer the physical base. Does everybody understand that? Sweet. Okay, so again, this is the same, except the base shape doesn't repeat. The base shape shrinks to a single point. And again, it's the same thing. It can be a rectangle, it can be a triangle, it can be anything you want, right? So we have rectangular prisms, which we drew there. We also have square prisms, right? When the bottom is there, these are both the same. And then we have triangular prisms, which are really weird to deal with, right? And they're hard to draw, too. I like to draw a triangle prism by doing a short line there, a long line there, and then connecting them this way. With the you have to draw this diagonal one in the back. I know, they're really hard to draw. This is not an art class. I'm never going to challenge you to draw these, okay? But I need you to be aware that this dotted line right here shows that I do not have a square or a rectangle like we did here. Okay? So how does this affect you guys? If you're doing a surface area of a triangular prism, it's 4 triangles, isn't it? Right? Whereas this guy is 4 triangles and a rectangle. Cool? Everybody good? All right, and of course there is a special circular pyramid. What do we call that? A cone. Because we start with a cone on the bottom, a circle, or if this was the old days, a dunce cap, and it would go up like that. But nobody has to wear those things anymore, which is good. I think that was pretty cruel back in the day. Go sit in the corner with this hat on your head that says you're stupid. It's a stupid way to punish people. So that is a cone. Now a cone is simply a circular pyramid. Is everybody good? Okay. The first one we are going to do is indeed easy. You did this last year. It's review, stay cool. But last year, your teachers taught you, well, depends on who your teacher was. So we are going to draw and calculate the surface area of this cereal box with those measurements. Now you guys have to be smart, right? You know what a cereal box looks like, yeah? It's got a tall side. It's got a short side, and that's the front, which is going to make a rectangle, yes? And then it goes backwards at the corners to make the sides where you get read all your nutritional information and such, yes? Now be smart. Where do these measurements go in this drawing? Where is the 8? The depth, yes? Because that's the shortest distance, right? Where is the 40? The height. We would call that the height, wouldn't we? And the only measurement left is here, 24, yes? Now in the 9th grade, a great many of you were probably shown this. This is technically 6 rectangles, isn't it? Right? It is this rectangle. Right? It is this rectangle. And it is this rectangle. Agreed? Then you would add it up, multiply by 2, yes? Everybody cool with that? Everybody was shown that at one point in the 9th grade, yes? Okay. Some of you hopefully were shown a formula for this. Right? And that formula exists in your books and in that data book that I gave you yesterday. The formula looks like this. You don't need to flip to it because I have it on the screen right here. The formula looks like this. Here's the problem. If you don't know what you're doing and you go straight to a formula, this gives us a nice formula there, yeah? Except this box is not the way we have drawn our cereal box, is it? This is the way, this would be our cereal box that was lying flat on the ground, right? That is where the problem happens. You guys, not you guys, you're smart kids, but every so often people will look at the formula and they will fill it in wrong because they aren't looking at what they are doing. They are looking at how to use the formula. Do you understand the difference? It's similar to science. In science, we ask a question, then we do some tests, then we get a conclusion, right? Would you be able to do science if you said, well, I know my conclusion, let's go back and make up some facts to fit that conclusion? Is that how we do science? No, it's the same in math class. Don't look at this and try to find what fits this. Look at what you have and fit it to here. Understand? So, there is our formula, 2WHLWLH. Okay? So if I go back to my drawing, I need to label these, right? If I label them, it becomes super easy. You can't do it wrong if you label it, right? Does it matter how I label them? No, because we're multiplying. What would you guys call this 40? The way we've drawn it. You would call it what, Max? A. A? I would call it H for height. Cool? What would you call this? L for length. Then what would you call this? W for width. See what I mean? It's weird, right? It's hard to make this drawing fit the formula drawing. Do you understand what I'm saying? So Max said, well, I would just call them A, B, and C. I assume that's where you were going, right, Max? Is that okay? Of course it is. You can call it anything you want because the letters are only there to substitute for the numbers. Okay? Could you call it lightning bolt, fish, and star? If you wanted to. Okay? There's nothing math teachers hate more than hearing kids like you say, I can't do that question. Why? Because it's got different letters. Navneet is laughing, but I've had many kids, I have given them this question. Why 7 and 12 and told them to find why. Like, I can't do that, Mr. Myers. Why, kid? Because the formula for Pythagoras is a squared b squared c squared. That's a why. I don't know how to do that. And you are laughing, but that is the majority of your peers. Okay? Don't be those kids. Got it? Letters don't matter. So, if I were doing this question, I, of course, would write it out. 2 WH HL LW. Then you just fill it in. Now, the mistake that you're going to make next is you're going to punch it into your calculator wrong. It's not your fault, but you're gonna. Because you're going to not do work and be like, oh, I can do this. It's just calculator. Just go. I got it. Go. So you start punching this into your calculator and you get a number. You guys being kids raised in the 21st century, you think your calculator is right, no matter what. I have had many of you hand in work to me with an answer that can't possibly make any sense. And your reason is not, that's the math I did. Your reason is, my calculator said so. Really? Your calculator's your best buddy, like that movie where Joaquin Phoenix falls in love with Siri. Your calculator's not a real thing. It does what you tell it to. If you tell it garbage, it gives you garbage. That is an internet or a computer programming thing, like LOL. Computer programmers call it GIGO. Garbage in, garbage out. If you tell your calculator to do the math wrong, it's going to do the math you tell it to do. It's going to be wrong. It's going to give you the wrong answer. You're going to hand it in to me. I'm going to say, what the heck were you thinking, kid? And you're going to say, a calculator said so. Calculator. What's the surface area of a cereal box that's 24 by 8 by 40? It's not telling me. Because it's a piece of machinery that you have to tell it what to do. So tell it what to do right. And the only way to make sure you tell it what to do right is by writing it down. Because a great many of you are going to punch this into your calculator and you're going to get the wrong answer. Because you don't know how to use this properly. Okay? So if I were doing this question, I would write it out. WH, it doesn't matter what they are. On mine, it's 40 and 8. Yes? And 8. Plus HL would be 40 and 24. Plus LW is 24 and 8. Now, here's the mistake you're going to make. A great many of you are going to punch this in, and you're going to do 40 times 8. Good job. But then you're going to multiply. You're going to do 40 times 8 times 40 times 24 times 24 times 8. And you're going to get a colossally huge number. And then you're going to write it down. And you say, yep, that's surface area. I punched that in. Calculator told me. And you're going to walk away. And I'm going to give you 1 out of 4. And you're going to be like, I've never gotten lower than 5 out of 4 on anything. And I'm going to say, well, that's because you've had the last 8 years of doing the exact same math over and over again. That changes now. So everybody can go ahead and punch this into your calculator and just see if you can get it in one step. I know what the right answer is. No more writing. See if you can get it in one step on your calculator. Some of you will, some of you won't. The lesson I am trying to get here is don't try. No. Try with your calculator. But some of you are going to get this answer wrong. Should you? This is not hard to do, is it? It's 3 multiplies, a 4th multiply with some adding. You should be able to do this with your calculator, shouldn't you? So go. No more writing. Make this come out on your calculator in 1 try. Which means you get to hit equals once. What is it? That is exactly what it is. Now, with your type of calculator, Tavleen, you have the one that prints, right? As you hit buttons, it puts them all on the screen, yeah? Yes. If you have one of those calculators, this is so easy. You punch in what you see. But if you don't, it's a little more difficult.
What's the answer?
2,944. You got that? See? Navneet, did you get it in 1 try? How many people got 2,944 on their first try, punching it in without writing anything else down? And how many people are teamed up to try and make it happen? No, of course not. That's the next thing. You needn't write it out like that. Okay? Why I write it out like that, Bavneet, is so you can never do it wrong. Because if you write it out, you can't possibly do it wrong. Because where do most of you make your mistakes? Texting thumbs. Trying to punch 27,000 things into your calculator at once to avoid showing work. Okay? The way I do this question now, even though I can do this in my head, is I write it out. 2, that's 320. That is 480. And that is 192. Then I add that up. No, that's not 480. That's 960. Sorry. I forgot to double it. That's 960. Then I add that. Then I multiply by 2 to get 2944. If you're going to try punching that in 1 time in your calculator, you got to get good with the brackets buttons. Okay? This is not a course in calculator usage. Also, all of you have different calculators, which is a super pain in the ass, which is why I am showing you write it out. Okay? Because it's real easy to get the wrong answer. This is the easiest formula you get this year. And a bunch of you had trouble getting that in your calculator in 1 try. Right? And this is the easiest one you're going to get. So please, 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 pay attention. The math in this unit is not difficult. It hasn't been difficult. It's been 1 or 2 calculations, right? But it's very picky, right? It's very picky. The way that's written out is even picky, with a multiply and an add, and a multiply and an add, and a multiply and an add, and then the whole thing multiplied again. Cool? All right. Let's go to the next question. Draw and calculate the surface area of a rectangular pyramid with base dimensions and a height. So first of all, we got to draw it. The base dimensions are 32 by 48, yes? So I need a rectangle that is 32 by 48. Cool? Now, since it's a pyramid, we're not going to be able to see the back, are we? So I'm going to have this triangle in the front. Yes? And I'm going to have this triangle on the side. Is everybody cool with our pyramid? Okay. Now, if you look on your data booklet, you see that the surface area of a square-based pyramid is right there, yes? Do you see the surface area of a rectangular-based pyramid anywhere? No, you do not. So again, you have to use your brain. But you do see the triangle is right there for each triangle, and the base is right there. Base in a square-based pyramid is B times B, yes? Do we have a square base pyramid here? We have a rectangular base pyramid here. So can I do b squared? What do I got to do? What finds me the area of a rectangle? Length times width. So again, I can't use a formula here. I have to think about what I have. What do I have? I have a rectangle plus 2 triangles for these two. I'm going to do this in color to make it easier for us. I got 2 of them, don't I? So that's 2 red triangles plus, and I got 2 black triangles, don't I? Everyone cool? Okay. So now all I got to do is do some thinking. Now listen to me. If you write it out, again, you can make your life so much easier. Okay? This is simple. It's length times width, right? Plus. Red, what's the area of a triangle? It's 1/2 base times height, yes? But I had 2 of them, didn't I? So what do I get to do with that 2 and that 1/2? They're canceled out, aren't they? Because what's 2 times 1/2? 1. So that can disappear, can't it? Right? Plus, I had 2.5 base times height for the black triangles. What happens to the 2.5? They're gone. Now, before I've even touched a number, have I made this way easier on myself? Of course I have. So now, all I got to do is fill it in. Here's where you're going to make a mistake. Again, this says height, right? Right? Height of what?
65.
That's the mistake. Why is 65 not the height? Ayesa. Other way around. The height is straight up from the middle, right? How tall am I? From my feet to the middle of my head, right? 5'8". Is my height this? Around here, up here, over my knee, up here, around my belly, over my boobs, up here, around my chin, around my nose, and up to here? No, that is not my height, is it? But that measurement is needed for my surface area, is it not? Because the front of me is a surface, yes? Height goes straight up, damn it, the middle of the pyramid, yes? So do I have a height to this pyramid? Yes. So this is the hardest surface area question I can give you. That's why it's in your notes. Don't draw it. Don't draw what I'm about to do. Let's just talk about it. Because if you try to draw it, you're not going to be thinking. I have this at 32, yes? And I have this at 48, yes? I have no height, do I? Not on the sides of the pyramid, because as Ayesa says, the side of the pyramid is slanted. It must be taller, yeah? So what do I really have? I have this height to the middle of the pyramid is how big? 65. Does everyone agree there? 65, right? I need the height up the side of the pyramid, don't I? I need this slanted height right here, yeah? What is this distance from the middle of the pyramid out to that edge? 16, correct? What is the height? 65. So now what do I have? I have a triangle that is 16 and 65, and I need the hypotenuse, don't I? Everybody with me? Now, how easy How easy is it when we discussed it? Not that hard, is it? But when I asked you, what's the height of the triangle on the side? What did you all say? 65. Why?
Because it said the height.
Because the question said height of 65. Now, some of you I probably didn't fool the first time. That's okay. That's good. I don't want to fool all of you. But most of you got fooled, right? You have to think about what is happening. There's height, and then there's height. Understand? Picking up what I'm putting down? Again, not complicated. Not complicated math, complicated wording. Understand? So what do I got to do here? Well, I know I have this one, which is 65, 16, and I need that, correct? That goes with the 48. Is that the black hypotenuse or the black hypotenuse or the red hypotenuse? With 16 here, then is this going to be the red one or the black one that I'm getting? Talk to your neighbor. There's a reason we're doing this. This is complicated. Is it the black or the red?
Black.
How many people say it's the black one? Be strong. How many of you say it's the black one? How many of you say it's the red one? How many people are wusses? It is the red one, isn't it? Why?
Oh, because it's the side.
Because the 16 went out here. This is it. Right? So I am getting the red side. So this is the red height. What would the black height be? Still 65, but what would this part be? 24 to get the black height. Everybody understand? Who doesn't get it? Yes, of course I can. Which one? The red, the black height, or both? Okay. I need to know where you're having your trouble. Are you comfortable with the height of the pyramid from the peak to the middle of the bottom being 65? Are you cool with that? Okay. So you are all okay with that, right? Don't draw this. Okay? Now, you know I need this height up the side, don't I? Okay? So from the middle of the pyramid out to the right is how far? Half of 32, right? Because I went from the middle of the pyramid out. The whole bottom is 32, so this is 16, yes? So this gives me the hypotenuse going up the right side of the pyramid. Cool? Okay. Now, if I want the hypotenuse going up the front of the pyramid, I still have this 65, don't I? But now I am going this way to the front of the pyramid. So it becomes half of 48. Cool? Everybody good? Now again, is this complicated? No, it's 4 triangles and a rectangle. If you were in grade 7 and I drew this with a height and everything, and then I drew this with a height and everything, and then I drew a rectangle and said, tell me what 2 of them, and 1 of them is, could you do it? That's all we're doing here, right? Right?
When I thought when you got the bottom, the 16, I thought you subtracted 48 from 32, not 10 half.
Oh, there's the... Okay, fair enough.
That's what I was confused about.
It just happens to work out there. Yes. Okay. Are we all okay? So now, I got to find those red and blacks, don't I? Right? So the red guy, which was, I can't remember because my computer's acting up on me. This was red, yes? So the red guy is going to be the square root of 65 squared, plus 16 squared, right? Everybody cool? And the black height is going to be 65 squared plus 24 squared, and square root that. Can we do that in our heads? Of course not. We're going to use our calculators, yes? And what do we get? You get I want to keep that red. You get 66.9. And in black, you get 69.3. Now, again, we're back to the problem with how our calculators work, right? So let me see your calculator. Show it to me. Okay, so that one is, for some of your calculators, to do this, you're going to go 65. You're going to hit the little button that says x squared, plus 16. Hit the little button that says x squared. Then hit equals. Then hit square root. Okay? If you have a forward calculator like Tavleen and Lauren have, it's a different order. You can do the whole thing at once. Okay, but it's up to you guys to figure out your calculators. Don't worry, I'm going to give you lots of practice on this, okay? But I can't teach everybody their calculators, all right? If you have a calculator like mine, that when you punch it in, it comes up on the screen, then it's real easy to do. This is like what Tavleen has. She can do this. She can go square root and then bracket and punch it all in at once. 65 squared plus 16 squared and close the bracket. That didn't work for me because my calculator is a bit more complicated than your guys's. And I think that, see, mine didn't work. Now it's working. So now, 66.9. See? But it's up to you guys to know how your machine works. Cool? Now, once I have those two numbers, this becomes super easy, doesn't it? What's the length and width of the rectangle? The bottom of our pyramid. 32 by 48, yes? The red triangle has what base? 48. And what was the red triangle's height? 66.9, yes? And what was the black triangle's base? 32. And what was his height? And then I just multiply it all together. Toughest question you're going to get. Is everyone okay with it? Why is it tough? Because it requires you to remember so much stuff from before now, yes? You have to remember Pythagoras. You have to remember how you use Pythagoras. You have to remember if it's subtract or add in Pythagoras. Everybody with me? And then we would just do that math. I'm not going to do that math because that's not the important part of this math. I trust all of you can do that on your calculator. Everybody cool? Did anybody actually do that and get an answer? Because I know a great many of you want to. What do you have, buddy? What you got?
6,964.8.
Yep. Who else has a number for me?
What was the answer?
You say yours.
No, I didn't.
You say yours. You say yours.
I did the wrong math
You-
course and it sounded familiar, so I was just like, wait a second. Hold on, there's...
Who has a number? Max just gave me one. What do you got, Dylan?
Well, I rounded them all before,
Yeah, okay.
but 6,960.
Yep. What do you got, Karina? Oh, trouble there. What do you got? Priyanka, what do you got? You got 954? 64. Yeah, 6,964-ish. So 6,960, you just rounded differently. Picking up what I'm putting down? Everybody cool? Now, please notice how calm I am that Dylan got 6,960 and Max got 6,964.8. And I got 32 times 48 plus 48 times. No, I'm doing something totally different. I can't be bothered. I would have gotten a slightly different answer because I would not have rounded there. I would have used my calculator with the whole screen. So I would have gotten even a slightly different answer from you guys. As the math teacher, do I care? No. Because I care about you guys being able to do this part. This is what is important to me, not this, unless your answer is idiotic. Right? Like I ask you how many steps it takes to walk to Chilliwack, and you say 3. You understand what I'm saying? If your answer makes no sense, I take issue with it. If it makes sense and you've shown me a bit of work, I can work with you. Okay? All right. Next one. Draw and calculate the surface area of a cone with a radius of 15 and a height of 22. Well, a cone starts as what? Circle. Only draw a smile because you're not going to see the back of it, right? Because our cone is going to grow up there. Now, a cone is technically, of course, a circle on the bottom, yes? And then it is, are there scissors in there? There should be. Who stole my scissors? There's pliers. Max, did you steal my scissors? Wouldn't surprise me. Just kidding. You're not that way. A cone, as everybody knows, is a quarter of a circle rolled into that. Yes? So it is this shape, right? Which is a circle, plus this shape, correct? You guys are smart kids. This is part of a circle, isn't it? So this area must have something to do with the radius and with pi, yes? Okay, now, this radius is also what when I roll it around? It's this line right here, yes? Which is also up the side of the cone. Is everybody cool? So, a cone surface area, if you look on your data booklet, which you don't need to because I'm just going to write it right here, the surface area of a cone is pi r squared. That covers the circle at the bottom, yes? Cool? Plus pi r slant. Okay, S. And I'm going to write S right here. S stands for slant, And it is the measurement up the side of the cone. Now look at the wording of the question and tell me what I have done there to make it difficult for you. Tavleen. I gave you the height again, didn't I? The height goes where? From the top where? Straight down to the middle of the bottom, yes? I don't want that measurement, do I? Doesn't help me. I need the slant height, which is up the side. You guys are smart kids. Doesn't that make the triangle that would give me that S? How tall is it? 22. How long is this? 15. So I can find the slant, can't I? Tavleen. Of course. What will I do to find the slant? Pythagoras again, right? So it's the square root of 15 squared plus 22 squared. That's going to give me an answer that you're going to round off. Now, again, where you round is going to change your answer. So just work with it, okay? Now, all of you can probably get to there, right? 26.62, blah, 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 blah. Now you have a choice. As you get better with your calculators, you can leave that on your screen and use it. We know that we need that slant height right here, don't we? Right? We need that 26.62 right there, don't we? So if we leave it on our calculator, it's sitting there for us to use. What if we accidentally push clear or screw up somewhere? Then we're going to need that back, aren't we? So what I like to do is I like to write it down, but I also like to leave it on my screen. Is everybody cool? Just in case I screw up, I've got it there. Yep.
Why do we put the square root? Why do we square root it?
Because at the end of Pythagoras, you have to square root. Remember?
Right.
It's just, Pythagoras finds you the squares, not the square roots. It doesn't matter. I like to. Everybody good? Now. So I've got, now here's the next thing that's going to be weird for you guys. Pi, what's my R? 15 squared plus pi times 15 again. Now I have a slant, don't I? The slant is 26.62 blah, 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 yeah? It's written on my calculator, so I'm just going to write it here. 26.62. Everybody cool? Now here's where it's going to get weird from the 9th grade for some of you. 15 squared is 225 pi. This is what I want you guys to start doing. Don't give me this value. Leave pi written like that. Is everybody okay with this? Because pi is not really 3.14, is it? It's 3.1415967, blah, 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 blah. Leave it as pi. Plus, now, here is where what I want you to do that is different. On my calculator, I have the actual slant height, don't I? That I know from my formula, I got to multiply by 15, yes? So right there, it's sitting on my calculator. It should be sitting on all your calculators. If I go times 15, I'm going to get that. That's where I want you to do your rounding in a perfect world. Do you understand? So what I have there is really 399.41, yes? 399.41 pi. Because that pi is still there, yes? Now I got 225 pi's here, and I got almost 400 pi's there, right? What do I do with them? I'm going to add them. So there's my 399, and I'm going to add my 225. And I'm going to get 624.41 pi. This is what I want this year. Do you understand what I am saying? I do not want a decimal answer beyond that one. Do not go further. Leave pi as pi. Do not make it a number. Is everybody cool with that? Because as you go further and further in math, you will never change pi from being pi. Okay? When we first taught you the area of a circle, none of you had a pi button on your calculator. We said use 3.14, didn't we? Then in grades 8 and 9, we started saying, it's not really 3.14. It's this pi button. And you were all like, oh, okay. Now, you leave it as pi. Got it? Everybody cool? All right. Now, if you are faced with a test where the answers have no pi in them, like it's multiple choice, then you got to figure it out. Do you understand what I'm saying? You would do 624.41 times your pi button to get an answer. But you wouldn't even need to do that, would you? Because pi is about 3, right? And this is 625 times 3. So it would be anywhere around 1800, right? Everybody cool? Okay. So now let's go on to the next one. The next one is easy. What is it? A pop can. A pop can is what shape? Cylinder. So it's a circle on the top and a circle on the bottom. Right? So 2 circles is what area? What's 1 circle? Pi r squared. I need 2 of them, so it's 2 pi r squared. 2 pi r squared, yes? Plus the rectangle, right? A rectangle, we all know, is length times width, yeah? So the width is the height of our cylinder, yes? What's the length? Circumference of the circle. And a circumference is 2 pi r, right? Or, yeah, 2 pi r. Right? Right? So I need to add 2 pi r. That covers the circumference, which is the length, times the h, which is the width. Now here's the next thing that's going to mess you guys up. That's the formula. Because when we envision a cylinder, how is it always? Standing up like that, yes? So height is right here until I do this. Now what's the height? Still here, right? It is not this radius. Cool? That's the next thing that messes you guys up. Twisting the shape around. It's not the height anymore. Yes, it is. When I lie down, I'm still 5 foot 8 inches tall. Okay? I'm actually not. I'm 5'7 3/4, but shut up. Okay? I round up for that much so I can say 5'8". Cool? Now, as soon as you see pi, what are you going to do? You're going to leave it, aren't you? Yeah, because we're not in grade 8 anymore, are we? It's not 3.14. Okay? So this is 2 times pi. What's my r? Radius. Do I have a radius in the question? I have a diameter, so what's my radius? 5. 2 times pi times 5 squared plus 2 times pi times 5. And what's my height? What's my height? 20. 5 squared is what? Five squared is 25. 25 times 2 is what? 50. So I got 50 pies there, yeah? 50 pies. That's how my height goes like this, Bhavneet, because I eat 50 pies. Have you guys ever seen that math shirt? Square root of -1 plus 2 cubed plus this symbol plus pi. 2 cubed is 8. I ate some pie. Math nerd joke. Because this is the square root of a negative number is an imaginary number, which is an I. 2 cubed is 8. That is the symbol for sum. Add up a bunch of things, and that's pi. I ate some pie.
Wow, that's so funny.
It's not funny, Lauren. You don't have to suck up. It's okay. Did I tell you the chemistry joke about the electrons? I lost an electron. Oh my God, are you positive? You do get it. If I lose an electron, I lose one negative charge, right? So you say, you lost it? Are you positive? Yes, I'm positive I lost an electron, and I'm positive because I lost a negative charge.
Oh, that was just a really bad joke.
No, that was a really funny joke.
I know.
When do science teachers tell jokes?
Never.
Periodically. Because of the periodic table, it's in periods. Cut it out. Okay. What's 5 times 20? What's 5 times 20? 100 times 2? So I got 200 pi there. I got 50 pies and then 200 more pies. How much pi do I got?
250 pi.
250 pi. And that's how we leave it in the 10th grade. Everybody cool? Of course, if somebody gave you a multiple choice test that had numbers there, you would circle the one that was around 750, wouldn't you? Because 250 pi is about 3. 250 times 3 is 750. Cool? All right. Everyone is Gouda? Everyone is Gouda? Great. Let me see your book for a sec. Wait, I have a copy of your book right here. I don't need to see yours. No. You keep yours. I'll look on mine. You guys all need to do for your homework. Page. Oh, there's no page numbers. 25 and 26 and 27. You're going to screw up at least. You're going to screw up at least 3 of them. There's like 12 questions there. I assume you're going to get 9 of them perfect. And 3 of them, you're going to make one little mistake on all. Yes, you are.
Okay, wait. What page are you going to?
Page 25, 26, and 27. You stop when you get to the next thing that looks like notes.
Okay. You stop when you finish the gym question.
Okay, and remember, what is happening the next time you come to class?
Test.
You have a quiz on conversions, which you do not need to have memorized. You get to use the data sheet. It's both in your coil-bound book, Emma, and I gave you a secondary data sheet that was 4 pages stapled together. I don't know, but I have...
Oh, wait. I think
It is in your coil, right there. You just passed it. Right, back. 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 Right there.
Yeah, I know this. We have this. Okay, never mind.
Then what are you asking?
Play during the test. No, we get it during the test.
Yeah, you get it during the test. Yeah, of course. Yeah.
Okay, what's number 1? I already finished it. It's 75.